Welcome. We have a few. Well, this is actually kind of it's not as cerebral. Well, yeah, it is a cerebral introduction to user defined data types. So what that means when I talk about user defined data types, the thing to keep in mind is that everything is a number. It doesn't matter what it is when you're representing it or working with it. It's either a number to another number that starts the next number of an action, whatever, and those actions are loaded onto the CPU, processed, and then and so forth. But it all comes down to a user, and user is kind of a misnomer, a software engineered or an engineered data type. And what that means is, if you're thinking about it, you're inventing a data type, but everything's a number. So what are you really inventing? Well, it would be how that data is represented. And that's going to be something that you get the feel of uh, with enumerations. Uh, and enumerations, and to some loose way, namespaces is kind of the first introduction into inventing your own data types. I want to talk a little bit briefly about the string data type. So I'm going to put that on my little stickies down here because we're doing enums. Because once we start going off once we tell PowerPoint to get lost, I gotta make sure I got something, and then string. Okay, enums, namespaces, and string. Let's begin with talking about what is an enumeration, because remember, this is your introduction to what a user-defined data type, and here's the reason why this is important, and to put the mind power into, because it's going to make it easier to transition into object-oriented programming. You're already doing object-oriented programming, but you're not creating your own objects, and that's when you start really creating your objects. When we use that term user defined data type, we're not talking about enums, we're talking about objects. So when we yeah that so an enum is just a very simplistic user defined data type, to the point where we don't even describe it as that. So that term user defined data type is more prevalently towards objects, and inventing or designing or engineering your own objects. Uh, but yeah, put the time into kind of what is that enum, and how does it work, and the implications behind it. And so I'm going to take you through that today. Actually, we're going to learn about namespaces and why they're important, and then of course strings. So let's continue on. All right, a user-defined data type is essentially laying out a blueprint of how data is going to be organized and represented, either through an object or, in this case, through an enumeration. There's also another way, is what we call a struct. So an enumeration is just a sequence of numbers. But each number in that sequence, you're able to give a specific value to. So yeah, whiteboard time. Yeah, scribbles. I have students, a lot of students are pretty visual. And it really helps when at least I'm scribbling something down as I talk about this stuff. You know, you got something to match it with. Let's see, whiteboard. So let's invent our special number system. We're going to have a special number system that we use to describe, well, what would be a sequence of numbers? What could a sequence of numbers describe? What about fruit? Couldn't you have a sequence of numbers used to describe different kinds of fruit? So any kind of sequence that you want to give a name to for numbers, that's what an enumeration is for. It's so that you can use natural language for a number, so that when you're writing the code and you're using that sequence of numbers, it's easier to work with. So here's what you would do is you would create an enumeration of fruit. And so the enumeration, the evented data type, is that fruit. That's the actual enumeration. And then that fruit can be an apple, an orange, whatever, you know, what, kiwi, you know, and I'm going to probably mangle. Oh my God, the scribbles are already back. Damn it, you stupid thing. Kiwi, okay, and give me another fruit, banana. That one, banana, whatever. Okay, banana. Okay, so this fruit, this guy right here that we call the enumeration or the data type, we say can be assigned to different values like apple, orange, kiwi, and banana. But the name fruit is not the actual data type. It's the definition of the data type. So first, you define what the enumeration is and what it can be assigned. And then you have to, what we say, and I'm going to use this term, instantiate the enumeration. So that's when you use the definition name, fruit, and you say, my lunch, meaning my lunch is the actual enumeration. We're just saying we're going to have a fruit called my lunch. And my lunch can be assigned an apple, an orange, or a kiwi. So this is the same thing. Saying fruit, my lunch, is the same thing as saying integer count. Because remember, we're calling this a user-defined data type. Well, what's another data type? Int. Int's a data type. Int defines that it's got a definition that it's a 4-byte number that is whole. There's no fractions. And then when we want an integer, we say int, I want an integer, and then we give it the name. So this is what you're actually designing, is the data type. So when you say fruit, the enumeration can be these different things. That's the definition. And so that's what I call definition code. That's definition code. This, when you actually instantiate or create the fruit from your definition, that's what I call runtime code. This is runtime code. Runtime code. Definition code. You're defining it. Now you notice I put the definition above so that then I can use it. So scope is important. Um, the fruit data type has to be defined before you can use it. So yeah, you're inventing your own int or your own float or whatever. You know, I'm using air quotes a lot today. I'm being stupid. I'm going to stop with the air quotes. I don't know. Maybe I'm being a little sarcastic. Probably. Or maybe I just need to drink some more coffee. Or talk to Sandra. Sandra always helps me out. Let's go back to the PowerPoint, and then we're going to get into some demo. What else can the PowerPoint? Okay, so definition code. We say, hey, what is the data type name? Fruit. And then these are the values that they can be assigned. So what are the actual values that are being assigned? Apple, anything that you do with an enumeration is always assigned the values 0 through, then the next one is 1, and then the next one's 2. Because remember, everything's a number. So what this apple actually is, the apple is actually the value 0. The orange is the value 1. The kiwi is the value 2, and the banana is the value 3. And now enumerations always are assigned these numbers. It doesn't matter. It's the names and the way it's organized that you're using. Because here's the thing, is when programmers first started out, they found themselves using numbers to associate with different values within a container, like fruit. Well, what kind of fruit? Well, fruit 0, fruit 1, fruit 2, fruit 3. And then what if I want, vegetables in there? And then all of a sudden I got 0s, 1s, and 2s for vegetables. So it became really difficult to write appropriate code. And so that's why we have enumerations. And also it's a good introduction to user-defined data types. And they're used a lot. How are enumerations used? Well, you don't see them a lot in what you guys are working with, which is the primitive data types, the low-level library. Where you see them used a lot is in like high-level library, high-level libraries. Java uses enumerations a lot. C# uses enumerations a lot. Yeah. Let's see, any kind of other SDK, Python's tkinter, which is a visual, a GUI, uses enumerations quite a bit. Any kind of higher level extended software development kit uses enumerations a lot. Anything where you're using a library to do advanced things, like maybe it's a text-to-speech library, and they have a enumeration for different modes of how that text-to-speech behaves, and the list goes on. So enumerations are used quite a bit to explain a sequence of values that can be assessed very quickly. So they're also the most efficient data type, user-defined data type that we have. Fastest and most efficient. The fastest and most efficient way to group values that all have something in common, but also need to be referenced separately. Fruit, vegetables, animals. Did you know that an insect is an animal? That blew my mind. Yeah, I was like, bugs are just bugs, man. What? They're freaking not animals. What? So that means every time I squish a bug, I'm committing animalcide? That's fine. I'll go on committing it. All right, I'm getting off track here. I don't know how that happened, but let's get back on track. Let's see. Um, Dang, I said get lost PowerPoint's pretty darn quick, didn't I? I think yeah, it starts at 0. Okay, here's another example: colors: brown, blue, red, green, yellow. And there will be a way to convert between the integral value of an enumeration. In fact, that's actually what we need to get into. I've actually kind of forgotten how to do it. maybe we'll talk to Sandra about it and see how that works out. Let's see. Enums conversion. We want the conversion to integral because sometimes that's very helpful. Conversion to int and for loops. Use of them within a for loop. Let's get to the for loop example in the PowerPoint here, and then we're gonna. Okay, yeah. So here's these are all definitions. This is all definition code. It's defining the name of the enumeration and then the group of possible values that are pre-assigned, starting with John here 0, 1, 2, 3, 4. And instead of working with numbers, we can work with, well, everything's a number, so that's kind of an oxymoron. But yeah, we can package those numbers up in nice ways. All right, where is the for loop example? Oh, this is kind of cool. You can check to see if it's equal to, and then the less than greater than would behave just as you would think, with that 0 to 5 pre-assignment, or with 0, 1, 2, 3 of each particular part of this. So let's see there. Oh, nice! It did a static cast for me. Great, that's great. Let's do that. Let's do that. Okay, we're gonna come back. Let's go. Let's get into it. Let's play. I don't want to. Wait any longer. Okay, let's get in and let's play with Mr. Enum. And we're gonna go with fruit. And it's going to be equal to, and this is where we put in our identifiers that are going to be assigned the numerical values from 0 to whatever. So it's going to be apple, pear, and peach. Let's start with those ones for now. All right, let's see what kind of problems we've created already. Because I'm pretty sure we created some problems. Let's see what happens. Control S. Where are you, Mr. My stupid keyboard. Function F5. Did you know that, I've been kind of getting into mechanical keyboards recently. Oh my goodness, so beautiful. I'm going to be getting more of them. I've got one for my main dev machine, and they're awesome. Okay, what did I do wrong here? Let's look at the PowerPoints, because I think no, I'm just being silly. Yeah, we don't do an assignment when we do a definition. Okay, so yeah, that's when I was trying to explain it. I kind of used that assignment. So let me see. I think I've got to reopen this up, but I believe we've got something that's working. Let's do this. I'm gonna kind of come back here. Oh my goodness. I opened it with the wrong version, and it was yelling at me. Which doesn't help you guys. Okay. All right. Sometimes this happens and you lose the target. And this is actually a good learning experience. But you will get this error. And I'm going to go off camera and fix this. But this will happen when you do not have up-to-date build tools. And or if you create a project with a version that's lower than a version that's higher than a lower version that you're working with, you'll get this error right here. So I'm going to go off camera, get myself up and running, and we will go have fun finally. All right, we're up. We're up and moving. We got this compiling. And I've actually kind of made a big boo-boo here. And that's good for our discussion. Notice how the examples in your PowerPoint are using all uppercase. Notice how I use lowercase. Now let's see if this works, because if I'm doing an integer ifruit equals to 0, or an integer ifruit equals to 1, ifruit equals to 0 is the same thing as saying I want a fruit called efruit for enumerated fruit equal to apple. Okay, and then I can output efruit as you know, I can use this identifier to describe what particular fruit I am using or describing within that scope of organized values. So you see here that integer and fruit are synonymous. They're being used the same way because we're actually doing the same thing. ifruit equals 0 and efruit equals apple. That's doing the same thing. When we say ifruit is equal to 1, we're doing the same thing as saying I want a fruit efruit. Oh no, I can't, and this should actually be bfruit or whatever. Two fruit, integer 2 fruit. And then we'll say enumeration 2 fruit equals pair. So this is the same thing. And this is the same thing. It's just more organized. And that's the idea of user-defined data types, is you're defining your own integer. You're defining your own integer. Just think of it that way. You're creating your own data type. And you use it the same way you use simple data types like integer, double, float, whatever. You just declare it and give it a name. And then you can assign it one of these 3 values. But what about that boo-boo? Well, let's just see if this works. What about that boo-boo? Okay, what did I do wrong? Does it work? Oh, it works. What happens if I just do a cout ifruit? What is it going to output? Let's see. Let's just run it. You see how it output 0? Isn't that cool? Oh, duh. I was being an idiot. E fruit. Because I got probably static cast it. Yeah, okay. That's what I thought. Yeah. It's just, it's at that basic level. Just a number. E2 fruit, that's going to output the number 1. Even though we're assigning it to a different name, but that name is just associated to a number. It's an alias. But that's just how that grouping is. So we've set up that we've got a box of fruit, and from that box you can instantiate and create an apple, a pear, and whatever, and use it. So the boo-boo. Here's the big boo-boo. We do not use lowercase when we're doing enumerations. We must use uppercase. Now why? Because it is not only a tradition, but also it makes the code easier to understand, because when we see something in all upper cases, we know that it's most likely an enumeration. And so when you get to those third-party software, SD, software development kits, you're going to be able to instantiate some enumerators that are used to describe things. And sometimes some functions will need an enumerator passed to it to perform a specific process differently based on it, because we can use it as kind of a flag to change behavior of our control structures. So you can do an if statement. The fastest if statement, excuse me, where did that come from? The fastest, when we build control structures on top of enumerations and switch statements, that is the fastest looping we can create. The most efficient. And again, it goes back to, that's money. It's money in your hand if you're able to develop something that's that fast. Okay, let's get into the for loop. Finally, we're finally there. Where was it? It was like over here. I want to make sure I don't mess it up. There. Okay. Okay, so this is just like a normal for loop. We've got our counter. It's an integer being assigned the value basketball, which is another integer. And let's look at it in real time with what we've got going on. Let's just get rid of this stuff. For, what do I have to have here? To walk through every fruit. What we can do is we can say, just like we would say int I equals 0, we can say I want a fruit called I equal to apple. And then we can say I is less than, as long as I is less than 3, I plus plus. No, we can't do that. We can't do that. We got to do I is, how did they do it? Oh yeah, plus 1. Okay, so they did it, but they had to cast it back afterwards in the for loop. So the update I is going to be equal to I plus 1. Let's see if that'll work without a cast. I don't think it will. Yeah, that's what I thought. Yeah, I have to cast it. We'll talk about this in a second. I have to cast it after I've done the plus 1 back to its fruit type. Is that the way? Oh, I put the cast in the wrong spot. There we go. So we got our update. All right. And then we'll all put I. Okay, let's throw in our thingamajiggers. All right, Apple starts out, that's 0. Right here. So you see here I'm saying I is less than 3. What is actually happening behind the scenes is I is being degraduated. It's being reduced down to an integer implicitly. It's automatically converting it, just like when we do a cout of I. I is a fruit data type, but deep down it's a primitive data type, and so we, the underlying lowest level of C++ will treat it as an int, which is what it is, and so it will degraduate to make the comparison. Then over here, we can't just assign a fruit to an integer. That's illegal. We can't graduate without explicitly converting it back to its fruit representation instead of being degraduated down to its integral representation. So to be able to carry out the I plus 1, it's going to implicitly degraduate the I, add the 1, and then that becomes the next one, which is 2, and then that is graduated back up to a fruit. And that's kind of how the mechanics work. Okay, so we should have cout I. Let's do an end line here. Oh my goodness, I need to get end out. Okay, good. Okay. Let's see. Let's do the function f5. There we go. 0, 1, 2. Okay. Now what ends up invariably happening is usually what we do is we do a switch. We'll do a switch on the fruit. We'll do a switch on the fruit. Switch, whatever. We'll do a switch on the fruit, and that will allow us for some decision making within a for loop. So it's really, really efficient and fast. Let's see. Let's do a enumeration with switch statement. Let's just get a good example of it. Okay, so this is kind of how it would look. In this case, we would be using the fruit. Now notice how they are, oh, this is not, yeah, okay, traffic light. So you see how they're using traffic light dot red here? That's where the beauty of enumerations comes through. Because this type of structure, engineering, is the fastest you can get for data that is organized, for organized data. So we're going to switch on, in this case, I, which is the fruit. And when I is, and we need to now, when we want to compare it with which fruit it is, but we want to use natural language, we will go to the data type itself and use the dot operator. So here I will use fruit dot, come on, the member access operator, not the dot operator. Dot, well, let's look at our example here that we pulled up. So you notice here we're using the name of the enumerator to access the different possibilities of that enumeration. And notice here we're using a traffic light instantiation to switch upon. Here we have a fruit instantiation called I that we're using for iteration, and we're using it for decision making. So right here, this would be fruit.apple. Then you would do whatever you need to do when it's an apple. And you can kind of pretend that, you know what the heck? Let's make sure. Oh God, simple. Yeah. You know, this is a good example of the nightmare that going between different languages, because I just started writing and talking about C# there, guys. Really. It's ridiculous. Okay. Because I was like, it can't be dot, because that's object oriented. And I was right. We got to use the namespace, and we're going to be getting into names. No, we got to use the member access operator. What is that called? Let's see. Name of in C++. It's the name resolution operator. Scope resolution operator. Name is part of scope. Okay, so I'm partly right. Going down the rabbit hole of different languages. So we access it in C++ with the scope resolution operator. I saw this and I'm like, oh my goodness, this is the wrong language. And I was explaining the wrong language. Oh my God. Okay, yeah. Welcome to my world, guys. Welcome. Come sit down. I enjoy having you. Okay, let's look at the example. So we have, what is it? What do we switch? And then we output the different values. So it would be cased here, cout apple. Oh, this would just, if this was a fruit packing warehouse, this is the kind of thing you would see in the code. Because they would be using fast code, because when you're doing fruit comparisons, you got to do it like 10 apples a second or 10 fruit a second usually. I have experience with that, by the way. Okay, so then orange here. All right, and then my little last bit T error. And now we're going to go demo and run this thing. Okay. All right, excellent. Control S. Now, let's set a breakpoint. Okay, we still got ooh, yep, yeah, don't want that. That's C#. What I just did, by the way, is called porting. When you take a language and you convert it to another language, we call that porting. And it's very common. And in fact, that's the reason for the invention of C Sharp and Java is so that you wouldn't have to do any as much porting because they do the porting for you in the common language runtime. Okay, let's go. Now we're there. Come on, give me some love. Come on. There we go. Switch I. Okay, so there's I. It's an apple. There we go, apple. Then the next one will come in. Fruit, pear. And the next one will come in, orange. Okay, so this is the fastest type of loop with decision making that you can create that has organized data. And you will often see software engineers try to arrange things in this manner because this is a very common thing. But what you will also see is this won't be a for. This will be just simply a while one until the button of the fruit packing line stops, something like that. And if it's an apple, put it in this bin, that sort of thing. So you'll see this a lot out in the workforce. All right, that's enough. Let's move on to Typedef. And Typedef is basically you want to kind of reintroduce a variable into a scope. You know what, guys? Let's because why does C++ have Typedef? Why is it? Why do we want synonyms or aliases to a data type? I kind of wanted to experiment with this a little bit. I wanted to go to Sandra and say, hey, Sandra, what do you know about Typedef? Okay. All right. Let's see. Hey, Sandra. Sandra. Come on, Sandra. I paid you yesterday. You got to be there. Maybe I don't have my speakers on.
Hey Josh, I can hear you loud and clear.
Fine.
Hopefully
Fine.
you can hear me now too.
Yeah.
Let me know.
Oh, actually, I paid you this morning, was it? Okay. So, Sandra, I'm here with my students, and I'm talking about the Typedef statement. Why does C++ need a synonym or alias to a data type?
Great question. The typedef statement or using in modern C++ allows you to create a synonym or alias for a data type, which can make your code more readable and maintainable. It can also simplify complex type definitions and make it easier to manage changes to data types in the future.
Wait a minute. So you can have a more complex, let's say, enumeration in another file and use a typedef to bring it into the current coding file, but have it be using an alias so that it's cleaner.
Exactly. You can define something complex like a detailed enumeration or a struct in one file and then use a typedef or using statement to create a simpler alias in another file. That way you keep your code organized and much cleaner, making it easier for you and your students to manage and understand.
Well, yeah, because I have this enumeration fruit, but what if I had the enumeration for all the possible fruits in the world? That would be a huge enumeration, wouldn't it? It would take up a whole file. And it would be it would be hard to read, wouldn't it?
For sure. Having that many entries in one place would definitely get overwhelming. Using a typedef or an alias would at least let you refer to it with a simpler name, and splitting it into separate files or grouping related fruits together could make it a lot easier to manage and read.
Okay, thank you, Sandra. I'll take it from here. I appreciate your time.
You're welcome, Josh. Always happy to help. Good luck with your class, and if you need anything else, just let me know.
Okay. Yeah, Sander gets a little persnickety when I don't pay her. Yeah. She's very useful though, especially. Yeah. Okay. Whatever. We're not going down the Sander rabbit hole. Uh, so that means then if this fruit were just huge enumeration, I wouldn't want it there. I would want to put it in a whole nother file, include it. I would do like this: include huge enumeration dot cpp or dot h or something, and then I would put the enumeration in there, and then that way I can say type def fruit. Let's call it a fruit, and then I can go down here and say a fruit is equal to simple, easy to maintain variable. Yeah, that's the reason for typedefs, guys. If you'll see a typedef, and basically it's going to point to a single file where a really long enumeration is at, or a whole bunch of enumerations, or where a huge struct is at. And this is mainly for what we call C programming. Structs and enumerations are down at the C level of C++. So you've been learning all about C right now. We haven't even gotten to C++. Well, okay, I'll take that back. The string data type is C++. Where are we at on time now? Whoa. Yeah. We're an hour in already, and we haven't even gotten through the string. Okay, guys, let's log on through some more of this. Well, we haven't even covered strings yet or namespaces. Sorry, guys, it's going to be a long one. Strings are actually, well, okay, let's back up. C++, because I've talked about C a little bit, but C++ is built on top of C. That means that everything that C++ is came from all the code and the tooling that was built using the C language. So C++ is just kind of C extended with object orientation, and it's, C and C++ are what builds the other languages now, these days, especially for like those tertiary upper level languages. Python is an exception. They use C, not C++. But yeah, I mean, pretty much most languages. So when we talk about strings, what we're actually using is a C, what's called a C string. So what is a C string? Because a string just contains a C string. And a C string is C for a character array, or a sequence of chars, or a sequence of characters, and they're the characters from your keyboard, from the ASCII code chart. So what is a C string? But the problem is with a C string, you have to end it with a \0, because if you create a C string, it has no knowledge. It has no knowledge of how big it is. It does not know how big it is. That's why they have to put the stupid \0 at the end, so it knows when the string, when the sequence of characters is over with. So a string data type contains a C string, but it doesn't need the \0 because it also creates inside of the object an integer called length. So a string data type is a C string that has knowledge of its own length. And not only that, it's a C string with functions that can act upon it inside of the string library instead of using other libraries there's string compare, string copy functions, all these. Here's what I would suggest: do a deep dive on what a C string is. String compare. How does a C string compare strings? Look at that. That's important. And I would say then, how does string copy work? And yeah, how does a C string compare strings? String compare. Do a deep dive on that, but let's talk about strings. I don't know, let's just do here. What is a string? So we're talking about a sequence of characters. And actually, let's hit the PowerPoint here. And let's get into a little bit of what they have. The characters are based on the ASCII code that I've showed you. Yeah, it's like all the chars on your keyboard. And when I say char, I'm talking about characters. I know it's a weird way of talking. There are people that refer to CN as sin. So I think I'm doing pretty good. So they're ordered characters, and we can use one variable name to access all the characters in a string. And you can think of it as a collection of chars. So we're going to go on the whiteboard and show you what I'm talking about. All right. So say that we say string str equals hello. Those are double quotes and then a semicolon. What that does is it creates a C string inside, and that C string is a sequence of characters, and you can think of that sequence of characters as a box. And it actually is kind of a box because each character is assigned in RAM to a contiguous memory block. So H will go here, E, L, L, and then O, and then nothing goes here. That's just whatever. And then this will be assigned the value 0, and then 1, 2, 3, 4 for using the subscript operator to access it. If we want to output or do anything with it, we also can use the at function to directly modify the characters in a string. But the idea here is this is an array with contiguous memory blocks like all arrays. And the way the memory looks like is when you declare a string, the H is assigned, let's say in RAM, to address 3000. And each char or character is 1 byte. So then the E is assigned to 3001. Then the L is assigned to 3002. This all happens implicitly. 3003 and then 3004. So those are all your addresses in RAM. And you notice how they're contiguous. They're in order. 3001, 3002. That's to make it fast to get those values in RAM. And the string also has a variable called length so that you know when to quit parsing chars. So let's go play with it real quick. Then we got to get into namespaces, because I don't want to kill too much of your time for this module. Because I also want you to do, other stuff than what I'm talking about. Let's see. Oh yeah, string. Okay. Okay, we declare a string str equal to hello. Okay, then we can output cout str, and I usually refer to as of 0, and that's going to output the h. I can do a for loop that traverses the string, and here's the way I do it: str.length. That is a property. I think it might be a function, and I misspelled it. We'll see if it gives us errors. It's either property or function. Whatever language, I don't care. It's different in different languages. So I think in C++ it's a function. Other languages, it's a variable that they keep constant. All right. Yeah, it's probably a function because they might even use the \0 convention with the C string inside of the string variable, and then the length just counts up the characters. Yeah, whatever. No, it's not that inefficient. Oh, big problem, guys. I do this all the time. If you want complex string interactions, you need to include the string library, and then of course we want to open up the std namespace. Okay. You know what we're going to add to this list that we're going to do so you can understand namespaces is we're going to put an enum in another file, and then we're going to put it in a another file, and then put in a typedef for it, and put it in a namespace. That's going to be our demo today, guys. And actually, that's probably going to be separate. So we'll do this, and then we're going to we'll talk about namespaces a little bit, and then we will finish up with your full comprehensive understanding of namespaces within the scope of everything that we've been learning about when we do our demo. Probably won't be talking to Sandra for that demo. We'll be just doing it. Yeah, we'll get a little nutty. No, we're going to use Sandra. We're going to get a little nutty with the fruit. We're going to get a little fruity, nutty, whatever, and have some fun with it. I'm getting way off track. Okay, if we want to process every character in string, we would use the subscript operator with a number. Now we're going to use I to traverse through them all, and then do an inline. Okay. Let's look at it. Control S, function F5, which I hate. I got to get a better keyboard. I'm getting a better keyboard. I'm always getting a better keyboard, by the way. Yeah. All right. Yeah, we're walking through this. All right. Yeah. I is 0 at this point. We go down here, down to, we got to go to our autos. I is 0. str string. str is hello. str of I, look there. Value 104. H, that's its ASCII code value, 104. You can't really see it down here. But, so our first output is going to be H. Then I iterates, it's going to point to the E now, which is at the number 1 location. Now, when you're thinking back to some of my discussions on why we do everything 0 based, it's inherent. Because it's so physically constrained, the language itself is implicitly built with that behavior because the hardware itself physically only works that way. And I'm being a little abstract, so I'm not going to get too deep into it, and I'm already going off the deep end. Okay, going through here and all this stuff, we got I iterating all the way up until it's done and we have our output. Hello. Now we can directly edit. We have write privileges for, there's other languages that don't allow write privileges, but we have write privileges to the character or the C string inside of the string object with the at function. So remember this, guys, because this was a hard thing for me to kind of wrap my head around. So let's do this. str of 1 equals, and they're characters, so we can do this. Let's say it's equal to char 4. The character 4. Will that run? I think it will. Okay, you see we changed it to 4. So that works with the subscript operator, both read and write, and then also another one called at. I think that'll work. Yeah. And you can also use it here. Now this is kind of funny because you see this use of the subscript operator? Guess what it's using? The at function. Yeah. So software engineering, you want to be faster? You understand those things. You understand what is at the very lowest level of any language that you're working with for efficiency and speed. And in C and C++, you can go all the way down to the assembly level for speed. And that's why this language is king. It really is. It is used to build the bleeding edge of what tech is doing. It is used to build other languages. This is the language of an engineer. All right. Did we get through everything other than namespaces? Okay, let's do a quick nod to the headspace, the namespace. What a namespace is it's a way for you to create a region of protected code. And you define the namespace by using a name, and then you create code inside of here, and any variable you name out here, I guarantee you X is used in a lot of different libraries. And so what we found is that, if we had like a lot of libraries that we were including, a lot of third-party, secondary libraries, and often some of those includes would have inside of it a variable called sum. And the variable called sum is used quite a bit. SUM is a key word in some areas. Here it's not. We can actually use it. But that sum, this variable, sum, would clash with the sum in a library that I included and break everything. So what they started to do is let's throw underscores in front. Nobody's going to do underscore, and so they started creating libraries with the underscore. The newer generation of programmers comes along using those libraries with the underscore and says, oh, that's such a cool way of doing things. So they started using underscore as well. And so the engineers are like, yeah, that's not a good solution, guys. We need something different. We need a protector. And that's why you would put your sum in here And to be able to get to it, you would have to say using namespace MySpace, or you would have to use the scope resolution operator, and you would do it like this. What is the space? It's MySpace. You would say, I want MySpace sum equal to 3. And so it puts a wrapper around it. You have to walk through that door to get to that variable that's up inside of this box. You have to open this box. Here's the box to get to the variable inside. That's what namespaces are. Now I'm showing you a very simplistic view of this because we usually put namespaces in a namespace definition because it's going to be for a file that you include, for some other file, an outer external type of thing that you're going to bring in. And that's actually what we're going to do in the demo. We're going to do that and move on. So guys, wow, we didn't do too bad on time. It was great having you. I'll see you for the demo.